Hello everyone. In our previous video, we learned the basics of the BMS application and how to monitor battery data. In this video, we will perform a complete battery management system testing process using a battery pack emulator, BMS software, and a pack testing system. Let's begin. First, switch on the main MCB to power up the entire setup. Next, turn on the monitor and the workspace lights. Now, place the battery cells into the cell holders of the battery pack emulator. While inserting the cells, ensure that the polarity of every cell is correct. Incorrect cell polarity may result in improper operation and can potentially damage the equipment. After placing all the cells, the next step is to connect the battery management system to the battery pack. To do this, connect the BMS sensing wires to the cell push button terminals provided on the battery pack emulator. First, connect the black sensing wire, also known as the B0 wire, to the negative terminal of the first cell. Then connect the remaining sensing wires sequentially according to the cell arrangement until all cell connections are completed. It is very important to follow the correct sequence while connecting the sensing wires. Once all connections are completed, carefully cross-check each sensing wire to ensure proper connectivity and accurate voltage measurement. Next, connect the B terminal of the BMS to the battery negative terminal of the battery pack emulator. Then connect the P terminal of the BMS to the negative terminal of the pack testing machine. This terminal serves as the charging and discharging path controlled by the BMS. After verifying all BMS connections, use the adjustable configuration knob on the battery pack emulator and set the pack configuration to 15 cells. Now switch on the pack emulator display. The display will start showing battery information in real time. Here we can observe the individual cell voltages, minimum cell voltage, maximum cell voltage, and the total pack voltage. This allows us to verify that all 15 cells are detected correctly and functioning properly. Next, move to the computer and open the BMS application. After launching the software, click on the connection option and select the appropriate communication port. Once the correct port is selected, click Connect to establish communication between the BMS and the application. After successfully connecting the BMS, configure the battery parameters according to the battery pack setup. Since our battery pack consists of 15 cells connected in series, set the cell count parameter to 15S. After updating the settings, save and confirm the configuration. To verify successful communication, observe the RX and TX indicators. These indicators represent the receiving and transmitting of data between the BMS and the software. If both indicators are active, communication has been established successfully. Now move to the dashboard section. Here we can monitor all battery parameters in real time. The dashboard displays the voltage of all 15 individual cells, total pack voltage, pack current, state of charge, temperature, and various battery status information. Next, open the data logging section. This feature continuously records battery data and updates the parameters every second. We can observe the voltage of each individual cell and monitor battery performance throughout the test. The software also provides graphical representations of the recorded data. These graphs help us analyze voltage trends and understand battery behavior over time. Now that the BMS setup and monitoring process is complete, we can proceed with battery pack testing. Switch on the pack testing machine. Connect the pack testing hardware to the computer and open the pack testing application. Navigate to the connection section and establish communication between the testing hardware and the software. Once connected successfully, the application interface will display the overall pack voltage and pack current. Now move to the step programming section. Here, we create a test program according to the specifications of the battery pack being tested. For this demonstration, we are using a 15-cell battery pack. Each cell has a peak voltage of 3.65 volts, a nominal voltage of 3.2 volts, and a cutoff voltage of 2.5 volts. The first step of the program is the discharge step. We configure the discharge cutoff voltage to 37.5 volts, which corresponds to 2.5 volts per cell for a 15-cell battery pack. The discharge current is set at a 0.5 C rate, which corresponds to 7.5 amperes. After the discharge step is completed, we add an idle step. In this step, the battery pack remains at rest for 30 minutes, allowing the cell voltages to stabilize before charging begins. Next, we configure the charge step charge voltage is set to 54.75 volts, which corresponds to 3.65 volts per cell for the 15-cell battery pack. The charging current is set at a 0.2 C rate, which corresponds to 3 amperes. After the charging process reaches the specified voltage limit, we add the final stop step to terminate the test cycle. So, the complete testing sequence consists of discharge, idle charge. Stop after entering all the parameters, save the program and start the test. Once the test begins, the system automatically executes each step according to the program sequence. The software provides different color indications for each step, allowing us to easily identify whether the battery pack is currently discharging, resting, charging, or has completed the test. During the testing process, we can also evaluate the temperature monitoring capability of the BMS by observing the temperature data and the BMS response under varying conditions. Throughout the entire test cycle, all battery parameters are continuously recorded. After the test is completed, the software allows us to export the complete cycle data for future analysis, documentation, and report generation. In addition to numerical data, the software provides graphical representations of the charge and discharge cycles. These graphs help us analyze battery performance, voltage characteristics, current profiles, capacity behavior, and overall pack performance. By studying these graphs, we can evaluate battery health, cell consistency, charging performance, discharging performance, and the effectiveness of the battery management system. This completes the entire BMS testing process using the Battery Pack Emulator, BMS application, and pack testing system. Thank you for watching.